Okay, hello everyone. I welcomes to all in our lecture series on mathematical physics, that is your core paper 1 belongs to first semester B.sc Physics Hons syllabus. In this video or lecture we are going to discuss the topic on rotation of coordinate axis or properties of vector under rotation. Okay, so let's start. So to discuss about rotation of coordinate axis or properties of vector under rotation, first we have been considered a point P which is in a Cartesian 3D Cartesian coordinate system. Here this is the 3D Cartesian coordinate system XYZ, and let P is the point, okay, whose coordinate is X, Y and Z, and this vector represents the position vector R, okay. And here you can see that PC is the X component of this position vector. P F, here I drawn the perpendicular PF and PC on x axis and y axis. So OF is the y component of this position vector. Accordingly we can found the z component. Okay, here I not represented because I am going to rotate the xy coordinates or axis around this z, so I not represented the z component here. So this is the x component of this vector, y component of this position vector is your OF, right? Now we have to rotate x and y coordinate axis an angle theta about z axis. So this is the z axis which is pointing outward on the surface of this screen, and x, y both axes on this plane. Okay, now we are going to rotate x and y axis about this z axis an angle theta like this. So here you can see the new coordinate axes are x dash and y dash and z dash. So z and z dash remain same because z dash is not going to be changed, or the so-called z is not going to be changed over here. Only x and y changed when I rotated about this z axis. Let x and y axis rotated about this z axis an angle theta. Okay, now for x dash, y dash and z dash coordinate system, this is the position vector. If this is the position vector to the point P, now the new coordinate for this P will be x dash, y dash and z dash. Here you can see, if I am going to draw a perpendicular on x dash P to B, then this O to B is your x dash component in your x dash, y dash, z dash coordinate system. Likewise, if I am going to draw a perpendicular from P to y dash PH, then this is your y dash component. Okay, so the new coordinates of this point in x dash, y dash and z dash coordinate system is x dash, y dash and z dash. Now our work to find out x dash, y dash value and z dash value in terms of x, y, z and theta. Here you can see that as x and y two axes rotated about z axis, so only x and y component is going to be changed, but z component is not going to be changed. Z component will be constant. Okay, now we are going to find out x dash and y dash in terms of y, x, y, z and theta. So for that, here I drawn, you can see here I drawn a perpendicular on PB as CD. This is the perpendicular. Okay, now I drawn another perpendicular CA like this. Here I drawn another perpendicular from F to PH as PG, and another perpendicular FE on this OY dash axis as FE. Okay, this is the perpendicular. So 4 perpendiculars we have been drawn, right? Now here you can see that if this angle will be is theta, this angle also will be theta, and this angle also will be theta. How it is? Carefully you have to watch. I am going to explain. Okay. For that you just consider this point. Suppose A dash. Suppose this point is your A dash. Okay. Now you consider this triangle O, A dash and C. Here C angle, at the C angle this is 90 degree. Okay, this is 90 degree. So this angle, this entire angle will be how much? 90 minus theta. Okay. So if this is your 90 minus theta, so obviously this angle will be how much? This angle also will be 90 minus theta, right? These are two opposite angles, and this PC and x dash axis both are crossed with each other. So if this angle will be 90 minus theta, so obviously this angle will be 90 minus theta. Here PB is the perpendicular on the x dash axis. So this is the 90 degree and this is your 90 minus theta angle. So obviously this angle will be theta degree. Okay. Likewise, we can prove this angle also theta. How it is? You just watch carefully. Okay, here you can see that this angle is your 90 degree, this angle. Okay, because PB and PG, these two lines are perpendicular lines. So here this angle will be 90 degree. If this angle theta, then this angle is your 90 minus theta degree. Okay, 90 minus theta is your this angle. And here you can see that this angle is your 90 degree. This angle is your 90 degree. Okay, so this angle is 90 degree and this angle is your 90 minus theta. Obviously this angle will be theta degree. Okay, because here you can see 90 minus theta. 90 minus theta will be theta degree. Okay, this angle if 90 degree and this angle is your 90 minus theta, so this angle will be theta. So as this angle and this angle theta degree, so obviously this angle and this angle will be theta degree. Okay, now to find out the x dash y dash value in terms of x, y and theta, we considered, here you can see, we considered first OAC triangle. Here you can see this is your O, A and C triangle and this is your 90 degree. In this triangle consider cos theta. Cos theta means base. So this is 90 degree means this is your diagonal and this is your base. OA is your base. So OA by OC, OA by OC. Therefore OA will be OC cos theta. And OC from here O to C we considered as X. Okay, so it will be X cos theta. Now similarly consider PCD triangle. PCD triangle. Here this angle is your 90 degree. Now we are going to consider sin theta. So for this triangle sin theta will be height by diagonal. So CD is the height and PC is the diagonal. So CD by PC, right? So therefore CD will be P sin theta and PC sin theta. And here you can see P to C distance is nothing but y component in your x, y, z coordinate system. So instead of PC we can write y So CD we found y sin theta, right? Now therefore here you can see O to B distance will be how much? O to A plus A to B, O to A plus A to B. OA we found x cos theta and CD we found y sin theta. Here AB also equal to CD. AB equal to CD. How it is? Here you can see. Here this is the perpendicular. This is the perpendicular. This is the perpendicular. So AB distance. This distance will be equal to CD distance. So instead of AB we can write y sin theta because CD equal to y sin theta and CD equal to AB. So now here we found that OB, O to B distance is nothing but x dash. That is your x component in your x dash, y dash and z dash coordinate system. So instead of OB we can write x dash equal to x cos theta plus y sin theta. Let this is your equation number 1. Now you consider triangle PFG. So this is your P, F and G. In this triangle, here this is the right angle and this is the theta. Considering this triangle, sin theta will be FG by PF. Here this is the height, FG by PF is the diagonal. Okay, so sin theta will be FG by PF. So therefore, FG will be equal to PF sin theta. And here PF is nothing but x. Already we know this one. Here you can see O to C, if it is x, then obviously P to F distance, this one will be also x. So instead of PF we can write x and here is the sin theta. Okay. Now OH, O to H, here O to H distance is nothing but your y component or y dash, or we can say y component in your x dash, y dash and z dash coordinate system. So OH will be, here you can see O to E minus E to H, OE minus EH. OE we found how much? Here y cos theta I written, EH I written x sin theta. Why? EH equal to FG. Okay, EH equal to FG because here you can see EH, this distance equal to this distance because this is the perpendicular and this is the perpendicular, so this is the rectangle. So EH equal to FG. So instead of EH I can write FG and here we found FG equal to x sin theta. So instead of EH we can write x sin theta. So here we found OH is nothing but y dash equal to x sin theta I written first plus y cos theta. Let this is your equation number 2. Now as the axis rotated about z axis, hence z component not to be changed. Therefore z dash will be equal to z. Let this is your equation number 3. Considering now using equation number 1, 2 and 3, it can be written as in matrix form that x dash, y dash, z dash in a single column matrix, that is your 1 cross 3 matrix equal to a 3 cross 3 matrix is this one into x, y, z with another 1 cross 3 matrix. So here x dash, y dash, z dash, x dash, y dash, z dash matrix is equal to the coefficient. Here you can see this is your x cos theta, x cos theta, so only we are going to take cos theta, y sin theta only we are going to take sin theta, and here its z component is not there, z component is 0. In case of x dash there is no z component. Okay, so it will be 0, and in case of your y dash we can get x dash coefficient is your minus sin theta, y coefficient is your cos theta, minus sin theta, cos theta, and 0. In this equation here you can see z component coefficient is your 0 plus y component is your 0 plus z. So instead of uh, for the x component we are going to write 0, for y component it is 0, and for z component here the coefficient is 1, so we are going to write 1, and x, y, z. If I am going to consider, if I am going to multiply this with this, then I am going to get x dash. This with this one, I am going to get y dash. This row with this column, then I am going to get z dash. So in general, we can write this is, see, this x, y, z is the x component, y component, z component of this position vector in x, y, z coordinate system. Now it is transformed to x dash, y dash, z dash by applying this operator, this matrix, this 3 cross 3 matrix. Okay, so here r dash, that means here if I am going to write r dash, that means it represents the position vector in x dash, y dash, and z dash coordinate system. So r dash, that means position vector for this point in x dash, y dash, z dash coordinate system is equal to a operator or a matrix 3 cross 3 matrix into x, y, z in your x, y, z coordinate system. Okay, so here r dash position vector is written as is equal to r theta capital R function of theta into position vector in your x, y, z coordinate system. So this r theta, capital R theta, is called as, here you can see, this capital R theta, which is represented by 3 cross 3 matrix, this one is called as transformation matrix or rotation matrix. Okay, now if we consider any other vector such as a vector is your a, so its x component is x, ay, and az, and if we are going to try to find out its vector or its rotational vector or vector under rotation of x and y coordinate system, then it will be written as a dash. See, this a vector for x, y, z coordinate system. If I will rotate this x and y coordinate about z, then the new coordinate system will be x dash, y dash, z dash, right? So in x dash, y dash, z dash coordinate system, the vector will be called as a dash, and this a dash will be how much? R theta, that is your rotational matrix, which is operated on original vector which is in the x, y, z coordinate system, where ax dash will be ax cos theta, as we saw previously that x dash for the position vector x dash x cos theta, y sin theta. Similarly for here, for this case, ax cos theta, ay sin theta, ay dash will be minus ax sin theta plus ay cos theta. Here you can see y component is your x into sin theta, y cos theta. So similarly here ax sin theta, ay cos theta, and z component will be a z. So here a dash, if I am going to write, then I cap ax dash, j cap ay dash, k cap az dash. Here ax dash value is how much? This one, ax cos theta, ay sin theta. Ay dash value is how much? This one, and az dash value is how much? Only az, right? Now we are going to go for the properties of vector under rotation. So there are two properties, important properties under rotation. The first property is that magnitude of vector in primed and unprimed coordinate system remain invariant. So this is the vector in unprimed system, that is your x, y, z coordinate system, and this vector in your x dash, y dash, z dash or x prime, y prime, z prime coordinate system. So here we are going to prove that in both the coordinate system x, y, z and x dash, y dash, z dash coordinate system, the magnitude is invariant or magnitude is same. So here we have to prove a magnitude equal to a prime magnitude. So a magnitude will be how much? A x component square, y component square, that is a y square, z component square, a z square root over. Similarly, for a prime vector, that is your a prime vector, in general I cap ax dash or ax prime, j cap a y prime plus k cap a z prime. So a dash or a prime magnitude is your ax prime square, ay prime square plus az prime square root over. Now we are going to substitute the values of ax, ay, az over here. Here ax cos theta, ay sin theta square minus ax sin theta plus ay cos theta square plus az square. Here if you are going to solve this one, also you are going to get ax square plus ay square plus az square. Here I am going to solve for you. You just watch. You just consider this one. This is in the form of a plus b whole square. So this will be how much? ax square into cos square theta plus ay square into sin square theta plus 2 into ax ay cos theta into sin theta. Okay, consider this one. So this will be how much? Here you can see the minus and its square will be plus ax square sin square theta plus ay square cos square theta minus 2 into ax ay sin theta into cos theta. Okay, we just consider these two terms. Okay, so here we found this value and this value are both are same, got cancelled, and here we can take common cos square theta from this term and this term. So we are going to get how much? See, or here you can see I am going to consider, sorry, here ax square from these two terms. So we are going to get ax square cos square theta plus sin square theta. Okay, plus here ay square I taken common from these two terms. So ay square will be sin square theta plus cos square theta. Okay, so this value is 1, this value is 1. We found ax square plus az square, already az square is there. So ax square, ay square, az square root of. So here we prove that modulus or magnitude of these two vectors in both primed and non-primed coordinate system remains invariant. Right? Now another property is that invariance of scalar product of two vectors under rotation. That means a dot b will be equal to a prime dot b prime. These things we have to prove. So to prove the above property, consider two vectors such as a vector. We know that I cap ax, j cap ay, k cap az, and a prime, its corresponding a prime will be how much? I cap, this is the x component, j cap, this is the y component, we know that, and this k cap a z component. Likewise, b vector we are going to consider another vector b is this one, and its corresponding b prime is this one, x component, y component, and z component. Now first we are going to find out a dot b. So if we are going to consider a dot b, so this dot this this dot this, we are going to get ax bx plus ay into by az into bz. Now same thing, this value we are going to get if we are going to consider a dash dot b dash. So a dash dot b dash or a prime dot b prime is nothing but entire things I have been written over here. You watch carefully. This one I cap ax cos theta plus ay sin theta. This one, then j cap into minus ax sin theta plus ay cos theta, then plus k cap az dot, here it is written dot, carefully you have to write in your note itself, dot I cap this one, j cap this one plus k cap bz. Now we are going to consider the dot product. So I cap component will be multiplied, that is your scalar multiplication or dot product with this component, other component will be 0. So this will be ax cos theta ay sin theta into bx cos theta plus by sin theta, here I written. Okay, then this component will be multiplied with this one vectorially or scalar product, that is your minus ax sin theta ay cos theta, this one minus bx sin theta by cos theta, this one, then this one az bz. So if you are going to solve this one or multiply this one and this one, you are going to get at last this one. Here I am going to solve for you, you just watch carefully, you have to watch. I am going to multiply first this one. So what I am going to get here, ax bx cos square theta, ax bx cos square theta plus ax by cos theta into sin theta. Okay, then plus ay bx sin theta into cos theta, this is into cos theta. Okay, then ay sin theta by sin theta, it will be ay by sin square theta. Now we are going to multiply these two terms. Here you can see ax sin theta minus bx sin theta, so it will be how much, ax bx sin square theta. Okay, then minus ax sin theta, this is plus, so minus ax by sin theta into cos theta. Then we are going to multiply this term with this one will be ay bx cos theta into sin theta, then this term with this one will be how much, plus ay by cos square theta. Okay, here you can see that ax by cos theta sin theta, ax by sin theta cos theta, so these two terms cancel out, ay bx sin theta cos theta, ay bx cos theta sin theta, so these two terms cancel out. Here ax bx cos square theta, ax bx sin square theta, if I am going to take common ax bx, then this will be cos square theta plus sin square theta. So from these two terms taken common ay by, it will be sin square theta plus cos square theta. Already here az bz is there, plus az bz, so this value is 1, this value is 1. So we found ax bx, here ay by plus az bz. So these two properties are proved here. So thank you so much for watching this video. Thank you.